In the previous video, I showed you a demo so that we could begin understanding what determines the strength of the kinetic friction force. In this video, I'm going to summarize what we saw in that earlier video, and then we're going to develop an equation that we can use to calculate the strength of the kinetic friction force. So here is the experiment that we used in the previous video, represented as a force diagram. So the box was dragged along a table by a string, and there were four forces acting on the box. We had the tension in the string. We had kinetic friction pointing the other way, opposing the motion of the box. We had gravity pulling down. And then we had the normal force from the tabletop pushing up, opposing we had gravity pulling down. And then we had the normal force from the tabletop pushing up, opposing the downward pull of gravity. Here is the experiment we saw in the previous video, represented using a force diagram. So the box is being dragged to the right, and we have four forces acting on the box. We have the tension in the string. We have the kinetic frictional force opposing the motion of the box. We have gravity pulling down, and then we have the normal force exerted by the tabletop pushing up, supporting the box against the pull of gravity. You saw that as the weight of the box and its contents increased, the strength of the frictional force increased. So it's tempting to think that the weight of the box determines the strength of the frictional force. However, I showed you a little demo at the end of that video, which shows that in fact, the weight or the gravitational force on the box is not what actually determines the strength of the frictional force. In that last little part of the video, I pushed down on the top of the box, and you saw that when I pushed down on the top of the box, the strength of the kinetic friction force increased, even though the weight of the box did not change. Okay, so if it is not the gravitational force which determines the strength of the frictional force, what is it? Well, it is actually the normal force which determines the strength of the kinetic friction force. Okay, so here's how we can think about that. And I'm going to make a little table to summarize what happened in that earlier video. In one column of the table, I'm going to put the normal force. And in the other column of the table, I'm going to put the kinetic friction force that was measured. So at the beginning of the video, I had 20 pounds, in the beginning of the video, I had 20 newtons worth of stuff in the box. So there was 20 newtons of gravity pulling down, which means that we had 20 newtons of normal force pushing up. And with 20 newtons of normal force pushing up, we saw that the kinetic friction force was 5 newtons. Then when the weight of the box and its contents was 40 newtons, we would have then had a 40 Newton normal force pointing up to support the box against the pull of gravity. And with the 40 Newton normal force, the strength of the kinetic friction force was 10 newtons. When I had 60 newtons worth of stuff in the box, gravity was 60 newtons down, the normal force would have been 60 newtons up. So then the kinetic friction force would have been 15 newtons, as you saw in the video. So we see a pattern here. When we double the strength of the normal force, the frictional force doubles. When we triple the strength of the normal force, the strength of the frictional force triples. So this is what we call a proportionality relation. And we express a proportionality relation like this. We can say that the strength of the kinetic friction force was proportional to the strength of the normal force. So this little symbol here means proportional to. Okay, so proportional or a proportionality just means what I said. When you double one thing, the other thing doubles. When you triple one thing, the other thing triples, and so forth. Now, we don't really like to have proportionality relations floating around. We would rather have an equation. So to convert a proportionality relation into an equation, we introduce a proportionality constant. And the proportionality constant here is this symbol. So this is the Greek letter mu. And then there is a K subscript. The K means kinetic. Okay, so we have the strength of the kinetic friction force equals mu K times the strength of the normal force. And mu K here is what we call the coefficient of kinetic friction. Okay, so basically, bigger coefficient of kinetic friction means you get a stronger frictional force for the same normal force. So when is the coefficient of kinetic friction big? The coefficient of kinetic friction is big if you have a surface which is very rough or very sticky. So we can think of the coefficient of kinetic friction as a measure of the roughness or stickiness of the surface. Okay, so rougher or stickier surface gives you a bigger coefficient of kinetic friction. Bigger coefficient of kinetic friction means you have a stronger frictional force for the same normal force. So in the next video, we're going to use this relation between the normal force and the kinetic frictional force to solve some example problems, or one example problem.